Rising ocean temperatures drive many changes in the global climate that lead to the rising strength and frequency of severe climate events. Storms, hurricanes, and resulting winds and flooding are becoming more severe and have an increasingly severe impact on populations around the world. Atmospheric rivers, flows of water vapor through the global atmosphere, are another example of such climate events, transporting moisture and heat from the tropics to the poles, which are currently warming 4 times as fast as the global average. Since polar regions play a major role in moderating global weather patterns, understanding this process is vital for understanding the overall impacts of global warming. Increases in atmospheric rivers in the Arctic delay seasonal sea ice formation. During the winter, ice layers thicken and expand to shield the dark waters of the Arctic, forming a reflective cover that sends heat energy from the sun back into the atmosphere. With the increasing volume and impact of heat-fueled atmospheric rivers from the warming tropics, ice layers in the Arctic cannot fully recover, allowing the ocean to absorb more heat. Moisture from atmospheric rivers has an additional insulating effect as it traps heat like a blanket and warms the Arctic waters and terrain. Arctic ice is not recovering after warmer months as it did in prior decades. The HI-LAT-RASM project focuses on understanding the processes responsible for the accelerated warming of the Arctic Earth system, where the core focus area is the transport of heat and moisture from lower latitudes into the Arctic through ocean currents and atmospheric circulation. To explore these processes, the HI-LAT-RASM team has developed E3SM Arctic, which is a configuration of the Department of Energy's Energy Exascale Earth System model designed for studying the Arctic climate system. Configured on a global domain, it has regionally refined high-resolution grids in the Arctic in all its components. This allows for an accurate representation of fine-scaled transport processes that are important for the Arctic, for instance, narrow currents and eddies that carry warm Atlantic waters into the Arctic through the Barents Sea and Fram Strait, and Arctic cyclones that transport warm and moist air into the Arctic. These visualizations show results of the coupled ocean, atmosphere, and sea ice components of E3SM Arctic. In them, the effect of strong cyclonic winds on the ocean surface temperature are made visible using path lines in the atmosphere. Varying thicknesses of ice are shown by varying the transparency of the ice layer over the ocean, simultaneously showing the relationship between ocean surface temperature and sea ice. In one clip, the temperature through the depth of the ocean is shown on a particular transect of interest. Visualizations such as these provide an invaluable resource for understanding the results of climate models. They serve as a research tool by providing scientists with an interactive means of exploring their data to discover new knowledge, and as a means for them to convey that knowledge to the world at large.